Welcome back. We have come to the last video in this series. There are a total of 6. So if you've missed any, I encourage you to go back and get any of the practice videos that I've shown you. And today, I'm kind of excited because some of the items I'm about to show you, I don't know that people do this. I kind of, with my students, figured out a few cool things you can do with Desmos, and we have been using it and with great success. So hopefully the tips I'm going to show you today will be very, very helpful for you. The first thing you'll do is go to the page that I'm on here, and I will give you a link to that in the show notes. So go ahead and go down and get the link so that you can join me and work along with me as we work 5 more items in the official test from MAAP. When you get here, click on Subject Math, Grade Algebra 1, and Test Practice Session. Choose Start Test. Then you will continue. I like to X out of the tutorial. And then I'll go ahead and we'll click the blue button to start the test. Now the arrows on the top right are the navigation buttons, but the quick way to get where you're going is to click on the review button on the top left. And today the first item we'll look at is 46. And this is a inequality. Now this problem, your kids, if they're like mine, will type it in just as it appears. But you will quickly realize something's weird about this problem. So let me go ahead and type it in, and then I'm going to show you something. What you will soon see is that when you type an R into an equation, expression, inequality, whatever, Desmos thinks you're doing polar coordinates, polar graphing. And so it's using a radius and it's giving you a circle. And so clearly this is not going to work. This is not going to help your students solve this problem. So I tell my students when they are graphing inequalities of any kind, they are going to need to convert the variables in those inequalities into X's, or when there's X's and Y's, they'll use Y's. So I'm going to go back through here, and everywhere there's an R, we are going to use an X. You will have to tell your kids that, or they will not be able to do what I'm about to show you. Now, as soon as you put in the X, it will basically solve the problem for you. So here we have the point 1, 0 on the axis and a vertical line at the 1. And that's telling you that R is less than or equal to 1 is the solution. Now to verify that, you can come down here, don't type R, we're going to type X, less than or equal to -1. That doesn't work. +1, and that does work. I'm going to change the color here and see that that is the exact same solution. So all the values of X to the left of 1 work. None of these do work. Let's do one that's different just to show you. Let's try B. R, so I'll do X, greater than or equal to. And by the way, that's exactly how you type that. You type the greater than, which is on your keyboard. You shift and hit the button that has the period on it. Then type equal immediately after it, and it will put the two together. So let's do answer choice B to show you what that looks like. And see, it's showing you everything to the right of -5, which is not correct, because the solution will match the original inequality. And so X is actually less than or equal to 1. Correct answer is answer choice C. The next item is 47. So in this problem, we're given a quadratic function represented in a table, and we're looking for true statements about this function. So click on the calculator, click on the plus sign and table to add a table, and then duplicate the table that you see. As soon as you put all of the data in your table, you'll notice here on the bottom left corner of the same box, there's this Zoom Fit. If you click on Zoom Fit, it will make your graph show all of the points that are in your set of data. So click that. I had to click it twice, but there it is. And now I can kind of see the shape of a parabola taking form on the right. Now you can add more detail to the graph if you need it, but you may not. So I'm going to stop and not do that at this point because I think I'm going to be able to narrow down my correct answers with just what we have here. We can always go back and make improvements if they're needed. Okay, so the first statement it says is the function has a 0 at 0, -6. Now, what we have to remember is there is a parabola here that continues on. So it would connect all of these points. And one option is to create an equation for a quadratic function and put it on there. But for most students, that is not something they're going to do or even think to do. So I'm not going to use that strategy. Instead, I'm just going to graph the point that's in the answer choice and see if it makes sense. If it's something that might appear in this graph. And so quickly I can see the point 0, -6 not only makes sense, but it's actually in the table is 0, -6. But the question is that a 0 of the function? And the answer is no. A 0 of the function has to be on the x-axis, and that just happens to be the very next point. So I'm going to go ahead and label both of these. Hopefully your students know that both of those are not zeros. The only one that was a 0 would be the -6, 0. So we'll not choose the first answer choice, but we will choose the second answer choice. All right, the next thing it says, and I'm going to take these off, is the value of f of x is increasing on this interval. So what I want you to do is type that exactly as it appears. -2 is less than x is less than 0. And when you do that, you'll notice that it's shading in the graph. So the question is, are the points inside this region, are they increasing? Are they going up from left to right? And the answer is yes. Notice this blue point. It's down here, -2, -12, but this one's at -10, and this one's at -6. So as you move to the right, the graph is increasing on that interval, and so that is true. All right, so well, if it's increasing on that interval, obviously it's not decreasing on that interval, so the next answer choice would not make any sense. Okay, so the function has a maximum value. Well, this is kind of a tricky question, and we already know it's wrong, but I do want to show you how you would type this one in. So I would instruct the kids to type x equals -3 in and type in x equals -2 and look between those two lines. And I would like them to be the same color. So let me do that. Let's make them both green, so that I know which two lines I'm supposed to be looking between here. And I think I'll turn this one off. So let's uncheck that to get rid of it so we're not distracted. And so now we can really focus. In between these 2 points, it says a maximum value occurs. Well, actually, the vertex of this parabola is between those two. It would be somewhere a little lower than these 2 points. So right in between -2 and -3, there will be a vertex, but it's not a maximum. It's actually a minimum because this parabola would be opening up. So the only 2 answers that are correct are the second and the third answer choices. The next question is, we skipped quite a few here, is number 53. And this is a 2-part question. So we will have to answer both part A and part B. Here we have 2 accounts, and each account is growing. So the question is, which model best fits each? So what I would instruct my students to do is to recreate this table in their calculator. So we'll do that. Go ahead and open up your calculator and include a table. Under X, we're going to put our months, 0, 15, 30, 45, and 60. Under Y1, we'll put account A balance. And then we'll move this over just a bit and start a new column. We'll call this Y2. Just type a Y and a 2, and it will automatically subscript the 2. And then you'll type in the balances for account B. Now, once your data is in your table for both account A and account B, we're going to go ahead and graph this. You can't see any of the points on this graph, so let's press the zoom fit, and now you can see them. So the green on my calculator, that was my second, that's Y2, so account B, and my blue was account A. So the question is, which model best fits? Well, at first glance, I would say both of these look linear just from their appearance. They look kind of straight, but actually they're not. So we're going to look at the actual numbers to make sure of it. Let's start with the blue one, and I'm going to turn off the green one while I'm examining the blue one. I want to see if the blue one has a constant rate of change. Is it increasing at the same rate? So one way to do that is to get your differences. So I'm going to take 2650 and subtract 25, and I'm seeing 1.5. Let's take the next pair, 28 and subtract 2650. And really, I only have to do a couple, but I could do more. These are all 1.5 or $1.50 apart. So it looks like this account is adding $1.50 each time. So this is definitely straight. So I thought it was straight. I'm going to say it is a straight line. And if it's a straight line, that means account A is going to be a linear function. So we're going to choose that. So account B, let's turn off account A and turn on account B. Now this may look curved to you, but it doesn't look that curved to me. So what I want to do is I want to first check to see if it is linear. 29.02 minus 25 is $4.02. Well, I'm pretty sure the next pair, 3370 minus 29.02, is not $4.02. It's now $4.68. So it's not linear. So if it's not linear, it must be exponential because that's really the only two options they gave me. So I'm going to choose exponential for account B. So now let's go down to the next one. Based on the account balance information, which statement is true? Both are increasing by equal factors. Factors means you're multiplying. Well, no, I'm adding $1.50 on account A, so that can't be true. So I'm going to not choose that one. Let's use our answer eliminator and cross out answer choice A. Account A and B both increase by equal differences. Well, no, because I just checked the differences for these two right here, and they were not the same. So that's not true either. So answer eliminator, get rid of B. We're down to two answers. It says account A increases by equal differences. That's true because when I did account A and subtracted those numbers, I got $1.50 each time. And it says that account B increases by equal factors. Well, I haven't done that. So to be fair, I really should check. Factors means I'm multiplying by something. So to see if that's true, I'm going to take 29.02 and divide by 25, and I'm getting about 1.16. So let's do the next one. How about 3370 divided by 29.02? And look at that, 1.16. Now, the numbers aren't exactly the same, but they are very close to the same. So we do have a common ratio going on here, and that is an exponential function by definition. So the correct answer was C. Account A is increasing by equal differences, and account B is increasing by equal factors. Oops. Let's turn off our answer eliminator so that we can choose answer choice C. So the next item that we're doing is question number 54. This is a completing the square item, and we are asked to complete the square for step number 3. So here's the deal. In order for me to complete the square, I would need to know the process, but not completely. So let me show you some things. First of all, we're going to click on the calculator and we're going to type in step 2. You can type in all the steps. In fact, maybe I should just to show you what happens. I'll go ahead and do that. I'll quickly type in all the steps so that you can see what's going on with these. Okay, I have typed the given, the step 1, and the step 2. And so now I'm on to my step 3. So the question was, what are we going to add to both sides of this equation? So let's type x squared. Shift 6 will produce an exponent, and then you can type your 2 plus 16x. And then plus, I don't know what this is, so let's call it C. And then on the other side of the equation, I don't know what that is either. I'll just call it D. Any 2 letters will work, but they're not the same necessarily. You do add the same thing to both sides, but you're not going to get the same on both sides. All right, let's go ahead and click all. All right, now in order for this equation to be true, the intercepts have to match. So I've got a lot of stuff going on here, but I do know there's another x-intercept somewhere, and there it is. These don't match. So one thing you want to tell your kids is these have to match. If they are not matching, if purple doesn't look exactly like blue, and they can't even see purple too good. Let's make this brighter. I think I'll make the blue one orange. And then the purple one needs to match the orange. When it's right on top of it, it's right. But you know what? If they just slide these, they're not going to find it. So let me tell you how to find it. You can start with this equation, x squared plus 16x plus 8. So I'm going to go back down to the next row, and I'm going to use this same equation, x squared plus 16x plus 8, without the equals 0. Okay, and that will produce a parabola. The problem is this parabola is really big. I don't know if you can tell, but it's the blue one. Let me turn all this stuff off. You just click on these to turn them off. Let's focus on this blue parabola. This blue parabola goes way, way, way down. So if you click right here, the y coordinate of that parabola is at negative 56. I'm going to click on the graph settings. And I'm going to make this low number go below negative 56. Let's do negative 60 to 60. Why not? We'll count by 6. And then on the x's, I know that was at negative 15, I think. So I need to go past that. So let's do negative 20 to 5. We'll count by 5s. We'll label this with an x. We'll label this with a y. And let's look at it now. All right, so let's take a look. That looks pretty good. All right, there's the vertex. Well, I don't know if you know much about completing the square, but the point of completing the square for in our Algebra 1 classes is to put a parabola or a quadratic equation in vertex form. So that negative 56 is a big important part of that. And the number on the right will not be negative 56. It'll actually be a positive number always. So it's going to be a positive 56 because it would be on the left side and you would transfer it over to the right side. So that's telling you the number on the right side of the equation should be positive 56. And so the next thing is what would I put on the left side to make these match? Well, let's turn this back on for a second. And let's turn this one on for a second. Oh, I think I messed up. Let's see, that should be D. It should be 56. My bad. I put it in the wrong spot. All right, so I know D is 56. So the question is, where am I going to put the purple now if I know D is 56? So you can move this around, but again, you're not going to be able to get to it because look at this. I got to pull this way in here. So how am I going to find that number? Well, hopefully your kids already know how to complete the square. Half of 16 is 8. 8 and 8 is 64. But even if they don't, they can guess and check here. So I'm going to make this like a 50, which is not correct. And you see how those purple lines came closer to the x-intercepts? And then I'll make it a 60. Really close, but not quite. And then I'll make it 64. And look at that. 64 is right on top of there. So this answer is 64. The correct way to find it without your calculator is to take half of 16 and square it. And this number is -8 plus 64. But these tools that I'm showing you are for you to basically give your kids a way to check their work. And if they're having no success figuring out where it is, at least they can look at the vertex of the corresponding parabola to find some kind of number to use on that y coordinate. That -56 is a clue. There's a 56 in here somewhere. And then maybe they can figure out the 64 from there if they're not able to complete the square. The correct answers were 64 and 56. The last item we're going to look at, I'm most excited about, and that's because Desmos makes this item extremely simple. As long as kids understand the concept of functions, function notation, and how to set it up in the calculator, they will definitely get it right. And so I'm going to show you, first of all, click on the calculator, and we're going to type in actually two separate functions. We have no way of doing just a piecewise, but we can do two separate functions. And what I usually tell my kids is if it's a piecewise function with two parts, make one of your parts lowercase and the other part capitalized. And this is what I mean. For the first part, I am just going to use lowercase p of x, and I'm going to type x squared plus 5x plus 6. All right, but I don't want just that. I want to restrict the domain for this piece to only be x less than -4. So let me move this over. I really don't even need the graph to do this, by the way. Let's go ahead and shift and use curly brackets, just like they do here for domain. Curly brackets, type x less than -4, close curly brackets. And when you do that, you're only going to be looking at p of x with lowercase to the left of -4. All right, now for the other piece, use a capital P. Now you may be thinking, well, what if there's three pieces? What am I going to do for my third one? You can use anything you want. Use any letter you want. So you don't have to stick with P. You could do A, B, C. You could use whatever. So you're not restricted. But if it is just two, I tell my kids just use the same letter and make one capital and one not. All right, the domain for this piece will be x is greater than or equal to -4. X greater than equal -4. All right, so it's already created my piecewise function. That's great, but that doesn't help me answer the question. The question is, what is the range when the domain is given? And they give you a list. They give you a set here with 5 problems or 5 numbers. So let's put in a table. And in the table, I'm going to put my domain. So -6, -4 for my input. So that's going to go under x1. All right, so once I've inputted my table, my y values need to be my functions. Now I have two functions, so I'm actually going to use two columns. Where it says y1, I'm taking that out. I'm going to put lowercase p of x, but I can't just put x. I got to put x1, so it will know to plug in the values that are in the table. And right away, you see something, undefined. That's telling you it's not going to use that particular expression where it says undefined, because that's not, the domain is not there. Like that, those numbers are not in the domain, so you don't plug in -1 through 2, -4 through 2. It just says undefined. Now go to the next column. This time type a capital P of x1, and notice it says undefined only for the first one. So those other numbers are the output, and there's your answer. So I'm looking for an output that has a 12 in it, and it looks like the only two of them have a 12 in there, and then a 0, 2, 4, and a 6. So it looks like answer choice D is the only one that has exactly that output. So that is your answer. I hope you've enjoyed this practice series, and I do hope you get some good use out of it. If you need a copy of the actual practice set 3, it is free right now until next Monday. Go to my store. The link is in the show notes. And where it says bestsellers, I want you to switch that to most recent. And when you do, it's going to pull up my most recent things, which include the MAAP Prep series. There's 6 of these. The last one is now free, and it will remain so until next week. So please download it and use it if you want. The items in this practice set 3 are exactly like the practice items I just did with you. They're not the same items. They're same types of items so that you can practice the skills that I've just showed you. My next practice set, by the way, is going to be SAT, and I'm very excited that SAT has finally gone digital and has finally embedded this graphing calculator. So it's going to be so nice to see the difference and how the kids react to that test and how well they do on it. I'm real kind of excited. So stay tuned for that. That's coming on the 18th. But let me get back to this practice set. The answer document here is a paper printout answer document. Of course, you don't have to use that. They could just answer it in the test, or you could digitize this if you want. You could go to Edulastic, which is now called Pair Assessments, and there's a way to produce an answer document digitally where they can put all their answers in. You can even get an embedded calculator, Desmos calculator for Mississippi in your assessments, but you have to pay them money. You have to do a premium subscription to get to that, but I did it. I really loved pair assessments. So that's up to you. You don't have to do it. I've given you the link to the actual calculator. So in the description of this link right here will take you out to the Desmos graphing calculator. It'll say Mississippi right here, so you'll know you're in the right one. And then they can work on it. It is a little bit larger than the embedded calculator. You do have a little bit of a limitation when you're doing the one that's on their website, but it's still good to use this calculator because it is giving you the same functionality that they will experience when they're taking their test. If you have any questions or comments or need some help, please let me know. I'm always ready and willing to answer your questions. Y'all have a great day.